ClassLight is a software system that we've developed over about the last 12 years that allows users to map deforestation and forest degradation. The system takes in different types of satellite imagery that's freely available, such as from the Landsat systems, allows the user to bring those into the software and easily calculate the rates of deforestation, how much forest cover exists, and also other more difficult things to map, like the amount of disturbance or degradation in the forest.
My work is basically to work with institutions in Latin America, specifically in the Andes Amazon region, so that they use ClassLight. We now have ClassLight Online. We are still developing the tool.
Partnership between Google and Carnegie is interesting because Google has unique assets to do computing in the cloud, to bring in extremely large data sets, and to use some of their engineering genius to stitch that kind of computing environment together. And Carnegie's role is on the application side. How do you take those images and analyze them for deforestation and forest degradation? Both rely on one another to deliver to the end users the information that they want, which is the state of the forest over time using this incredible data archive that Google has put together.
It is going to be more interactive. It's going to be much faster. It is going to draw information from all these huge data archive that Google is providing.
And for scientists like me, we've been working and laboring over the process of putting together the kinds of data archives that Google is now launching with their Earth Engine API. That process for us can take most of our time in the science. What they're doing is helping us leapfrog directly over that process. What's incredible about that is our users are able to make the same leap at the same time that we are.
So it's going to make users' life much easier, for sure.
Amazon, it's a research institute dedicated to promote sustainable development in the Brazilian Amazon. We need ways to monitor forest change. So we decided to launch an independent monitoring system so that we could act against illegal deforestation. We report deforestation every month. We generate these maps. We provide information about the most pressured protected areas, but we underutilize the satellite imagery. So we end up extracting just a very small fraction of the information that could be very useful for decision makers to anticipate problems and stop, for example, the advancement of deforestation in the Brazilian Amazon. Google Earth Engine could provide information in a near real-time basis, providing data and the right tools to process the satellite imagery. So this is going to be a huge change in the way that we do remote sensing. What Google is doing is providing the tools, and people will use these tools to protect their environment. That's actually a service that Google is doing for the whole global society.
I am the head of international affairs at the National Forestry Commission, and I'm also the national red focal point. As such, I am also both part of the negotiating team for Mexico, and but I'm also involved in the development of the national red strategy. I think the new Google Earth Engine API is a great tool. I think it's going to revolutionize the way we conceive remote sensing data and geographical information systems in the same way as Google has brought other products in other areas. Mexico has made significant investments in the past in acquiring information about our forests, not only from remote sensors but also from local data. We have also a significant community of academics and experts on forests. But what we need in order for us to implement an effective RED strategy is to connect these communities, to find a way in which these communities of practice and this information is available in a way that can be blended to provide the best solutions to the toughest problems that we face. And in this context, Google Earth Engine is providing us with a platform that can facilitate not only the exchange of information and the processing of these mass volumes of data that are acquired every day through remote sensors, but also, and I think more importantly, to start building this common language across these communities of practice of remote sensing experts and land use planners.